Sorry about the mix-up on the torque lab. I was under the impression that that simulation would actually simulate this instead of tell you to do this. It's basically telling you what the instructions in the lab tell us to do. Of course, this is an introduction, the apparatus, which is right here, and the first step. So the first step is slide the hanger onto the 50 centimeter mark. I'm going to use this hanger, and this is just a plain meter stick. It's the best one I could find in my building, but it's still sort of iffy. So we put it right there, and hopefully I have this centered right. You can see that. Can't see the whole stick. Oops, sorry. Let me scoot it back some. So obviously this meter stick has been worked on by somebody because 50 doesn't quite do it. Place the knife edge on the grooves on the stand. You should attach the hangers with the adjustment screw on the bottom. Okay, did that. Although this is somewhat inconvenient, the system works much better this way. If the meter stick does not remain horizontal, move the hanger slightly until it does. Loosen that up a little bit. Apparently someone's whittled on this left end a little bit. That's pretty good. Let me tighten the screw down now. So, oops, I moved it. Let's see. Yep, I moved it. Tricky little devil, isn't it? All right. So that's actually, take this meter stick off here, you can see that this knife edge is setting at 50.5, looks like. So that's considerable amount. I should have found me a better meter stick. That's okay. We've done what we've been told. Note the hanger's location when the stick remains at rest. 50.5 from the zero end. Of course, that's going to be 49.5 from the long end. I mean the 100 mark. Since the forces on the stick must add to zero and the stand can only exert a force on the knife edge, it follows that the effect of gravity on the meter stick is a single force acting down at the point on the meter stick above the knife edge. So the force of gravity on this meter stick, we can treat it like it acts at the 50.5 mark. This does not determine the magnitude of the force. We need a little balance underneath of it or something. But it does tell us where the center of gravity is. So 50.5. Later on, we'll determine the mass of the meter stick. Okay. Second set of experiments. Leave the hanger at the center of gravity of the meter stick so that it can pivot on the stand about the point. Put 2 more hangers on the meter stick, 1 on each side. By the way, these hangers have a mass of 17.2 grams. 17.2 grams is the mass of these little hangers that I'm going to put on. Okay, so it wants 1 on each side. So there's 1. Oh, I picked up one without a screw in it. Probably one of my freshmen messed with that. I hate freshmen. Not college freshmen, high school freshmen. Okay. I love college freshmen. Put 2 more hangers on the each side. Hang different weights on these 2 hangers and slide them around. So I have some weights here. This hanger, these little plastic hangers, 6.5 grams. So I'm going to put 50 70. I'm going to put 70 on this hanger, so that's 76.5. And then I'm going to put on the other one, I'll put the 100. So this is 106.5. Okay. And then it tells us to slide them around until positions are located such that the meter stick remains horizontal. Okay, so I'm going to slide this one too far. Now I placed it at basically random positions. I could be moving either one. Let's see, move this one a little bit more. Just a little bit more. That looks like it's pivoting about the horizontal. It's rocking a little bit, but it's there. Okay, so I've already told you the masses of these. This one's position. Oh, I forgot my reading glasses again. Okay. This one, can you even see the left one? Okay. Sort of. Let me try to swing it just a little bit. I hope you don't nauseate you doing that. That would drive my wife nuts. Okay. So this one on the left is at 14.2. That's centimeters from this end. Now keep in mind the meter stick is at 50.5. So you take 50.5, 50.5, and subtract this 14.2 to get how far this mass is hanging from the center where it can pivot. Because remember, torques are taken about where it can pivot. So the torque from this mass right here is going to be from here to here. This would be the moment arm. So the torque would be this length times this weight. And that'd be the weight of the little hanger that's on the meter stick, the little hanger that holds the weights, and then the mass of the weights themselves. So it'd be the weight of this whole thing. Okay, so keep that in mind. Likewise, this one on the right end is at 77.8. My hanger's covering up the 77. So 77.8 centimeters, but you have to subtract 50.5 to get this length. And then you remember how much was hung there. Okay? So that these two torques should balance. So I'll let you fill out. You don't have to write a separate lab report on this. Just use this and turn this in. So that's this part. Okay? Repeat this procedure 2 more times with different sets of masses. Okay, so let's do that. Just to make this easy, you remember what I had on here was a 50 and a 20. So I'm going to put another 20 on this one. And I'm going to put a 50 on this one. So it had 100, now it has 150 plus the hangers. Okay, so I'm going to move these around. I'll move this one in to about there. And I'll just start moving this one until we get her balanced. Sort of like a seesaw. Well, this stick is all chopped up. This is sad. The ones over at college, it's weird. I have a lot better equipment here at the high school when it comes to electronic and digital equipment. But my manual equipment, the old school stuff like meter sticks, over at the college, they're in such better shape because of the maturity level of the students. College students don't tend to want to tear stuff up. High school freshmen, that's all they want to do. Let me see if I can break something. Okay, that looks pretty good. Let me see if I can stop this from swinging. Okay. All right, so the one on the left is at 19.4 centimeters from this end. Keep in mind, we need this distance, not the 19.4. And the one on the right is at 70.8. 70.8. Okay, now let me try one more different mass. We'll take this off. We'll put the 50 on. So on this right end, all we have is the 50 and the hangers. And on the left end, let's put let's put 100 and the 10. So we have 110 plus the hangers on this end, and on that end just the 50. Okay, so let's see if I can do it with just moving this one. Nope, that's about as far as I can go. So let me move this one in now. Too far. That was pretty good. All right, so on this end we have 24.3. 24.3 is where this is located. And on this end, I'm at 98.1. 98.1. Okay, so that gets us through page 2. And all this top page on part 3 is you're looking at that data. I mean, on here, you're just writing down the data, the numbers. On here is where you actually calculate clockwise torques, clockwise, so that would be that torque, and counterclockwise, this torque, and then you add those up. Theoretically, it should add up to 0. Okay, so let's see. Third experiment. Okay, you can use the condition for static equilibrium to determine the mass of the meter stick. Move the pivot hanger from the center of gravity and fasten it at the 40 centimeter mark. So I think they didn't say take these off, but I'll go ahead and do what it says. I'm going to put this at 40 centimeters. Okay. It says remove one of the other hangers and move the remaining one with some known mass on it until static equilibrium is maintained. You may have to change the mass on the hanger. So let's get rid of this one for the moment. And let's change this to, oops, I don't want to lose those. Those are expensive. Let's make this 50 grams right there. And let's see if we can even balance it with it. Yes, we can. Okay, so somewhere on here. So we have 50, but don't forget the small hanger and the hanger that's on the meter stick. Oh wow, got lucky, didn't it? That's pretty good right there. Now, here's what you have to keep in mind with this calculation of meter stick mass. The center of mass of the meter stick we found was 50.5, not 50. So here's what you have. Here's the torques that are in play right now. We have the torque from this mass hanging right here, gravity pulling down on this mass. And it is acting at 40 minus 14.9. This hanger's hanging at 14.9. So we have this mass acting at 40 minus 14.9, and that's a counterclockwise torque. And then we have the mass of the meter stick pulling down, gravity pulling down on the mass of the meter stick at 50.5. So 50.5 minus 40. So there's your two torques. Now, previously I'd have students say, okay, you have this much of the meter stick pulling down at its center, and this much of the meter stick, this 60% over here pulling down at its center, and they would calculate basically three torques. 40% of the mass of the meter stick pulling down at the 20 centimeter mark, and 60% of the mass of the meter stick pulling at the 70, and then this torque, and all three of those balance. But I did the calculations, you can do them yourself. That's the same thing as if the whole weight of the meter stick is acting at this 50.5 mark. Okay, so from this torque going counterclockwise, the torque from the weight of the meter stick acting at 50.5 this way, those two should balance. You should be able to calculate the mass of the meter stick. And I tell you, don't let me forget to get the mass of the meter stick so you can check yourself, but you're not here to tell me anything. All right, fourth experiment. Put the pivot hanger at the 40 centimeter mark and put one hanger and mass to the left of it with a, I'm not reading very well. Put the pivot hanger to 40 cent, we have that, and put one hanger and mass to the left of it with a different mass to the right. Adjust the positions of these two hangers and still static equilibrium. So I guess we're supposed to add a mass back on down here at the end. Okay, somewhere. And I'm just going to put it somewhere nice like the 80 mark. And it still has the 50 on it. And let's see, you may have to use different masses. This will not work for every choice of two masses. Okay, so let me add 100 on here. So now we have 100, just the 100. Let's see what happens if I put the 50 on there. Okay, so it's not quite balanced. Put a 20, so now that's too much. Take that off and put a 10 on here. Okay, so now I have the 100, the 50, and the 10, and then the mass of the hangers, and I'm going to move it until we get this nice and balanced. It's tricky, but I think that's pretty close. Okay, so what we're going to have in this situation is we're going to have the torque from this weight that's hanging here, and it's acting this far, which let me give you that number. Oh, it's exactly on 14 centimeters, 14.0 centimeters. Remember, I set this at 40, so this would be 26 centimeters is your moment arm and this weight. And then you have the torque from the meter stick acting at 50.5. Remember a minute ago, well, in the previous part, you calculated the mass of the meter stick. So you'll know the weight or the mass that you're going to treat like it's acting here at 50.5, which would be 10.5 centimeter moment arm times the mass of the meter stick. And then you have this torque. So you have three torques now. You have the torque from this one, the torque from the weight of the meter stick trying to rotate it, and then you have this torque down here, which I told you was just 50 grams, and I set it at exactly 80. Okay? So that lets you do experiment number 4. And let's see. Now use the condition that the sum of the forces equals 0 to find the force being exerted on the meter stick right here at the pivot point. Here's the idea. You have all this weight. You have this weight, this weight, and the weight of the meter stick itself, all pulling downward. I'm not talking about torques, I'm just talking about vertical forces. So all of those are pulling down. This weight, and the weight of the meter stick. And the only force you have up is this pivot point pushing up on the meter stick. So that force will equal the weight of all that we have hanging there. All right, now calculate the sum of the torques about other reference points. Let's only do one other reference point. Like it's random. You could choose any point you want. Like for instance, if we choose the 0 point, the end of the meter stick down here, think about all the torques. If this thing could rotate about this point right here, here's the torques that are in play. This weight would cause it to rotate clockwise, and it's acting at 14. This pivot point is pushing up on it with respect to where my finger's at. So that would be a torque counterclockwise. And in the previous part, you just calculated that force. Then you have the weight of the meter stick acting at 50.5 trying to rotate it clockwise. And then you have the weight of this one trying to rotate it clockwise. So those 4 torques should add up to 0. We'll see how close we are. You don't, bottom part down here, don't worry about that, okay? Just see if you can calculate these torques and see how close they add up to 0. So hopefully this gives you everything you need, to complete this lab. Sorry about the mix-up. I'll give you extended time on it, obviously, because it's not your fault. And you can email me with any questions you have. This is the data. You can even do screenshots of this, and if you're keeping a lab journal so that you can get lab credit, this will transfer to some other college. Then they may want to see your lab journal. You'll have to pretend like, hey, I did this, but at least it's just like you've done it because you're right here. All right, hopefully that'll help.